Welcome to the channel RIK Learner for KCET NEET. Here we are seeing a question. If block of mass m attached with a string of mass m and length L, then variation of tension in the string with x will be. We are given with this picture, and there is a kind of rope, what you can see here, right? So this is the rope to which there is a mass named capital letter M is suspended. The mass of this whole rope is M with small letter. The total length of the rope is L. And now we have to identify a correct graph among these four choices, where the graph has been drawn x versus the weight, otherwise tension. Well, the tension in the rope is acting upward, right? So as seen from this side, the tension is acting upward. See this picture, I will show you in a two different way. If this is the support and this is the rope, and here is the mass m, right? So if you don't neglect the mass of this rope, okay, so if you don't neglect the mass of the rope, so then as you come down, the mass beneath a particular level reduces. Okay, so when you move from top to bottom like this, the mass at this particular level is okay something, and when you go beneath this, the mass at this level is still less. Okay, so that means when you move from bottom to, I mean top to bottom, the corresponding mass of the rope, right, it decreases, right? So when you go down, the tension in the rope reduces gradually. Okay, so tension in the rope reduces gradually, and when you reach this point, okay, so this point, this is corresponding to a total length L measured from top to this point. Okay, so that means x should vary from x is equals 0, right? So x should vary from 0 to this point. This is x is equals L. When x is equals 0, the tension at this point becomes maximum. Okay, so tension at this point is maximum. If you see from bottom, the tension which is acting upward at that point is maximum. Okay, so when you come to this point, at this point the tension is minimum. So when you move from this point to this point, gradually the tension decreases. So tension decreases with the distance x linearly. Okay, so tension decreases linearly because so the mass of this rope is linear. That means the relation between length and mass are linear. The tension also depends on the length linearly. So for that reason, when you move from x is equals 0 towards some greater value, the tension in the string should decrease linearly, right? So it should decrease linearly like this. So T, okay, so T is directly proportional to L like this. Okay, but what actually x is measured from top to bottom. So that means here you should note that when you measure from the top, okay, when you measure from the top, this relation fails, and here you should write T proportional to minus of L minus x. Okay, so when x increases from the top, right? So L minus X decreases. That means tension also decrease. So for that reason, so here when you observe, we can avoid these two options, right? But these two options should be considered in mind. But one thing you must observe, when you reach this point, that is just above this point, right? At this point, the tension is simply equal to, here the tension is simply equal to T is equals, okay, so it's a minimum tension mg. Okay, at this point it is maximum, what I said already. So this is T is equals, okay, it is maximum tension. So this is equals m plus m into g. Okay, so what we have to consider, we have to consider when x is equals 0, the tension is m plus m into g, and when x is equals L, the tension is mg. So this is minimum tension, right? So in this picture we have to observe the same thing, right? When x is equals 0, tension must be m plus g. When x is equals 0, this is a point where x is equals 0, so the tension is m plus g, it is right. Okay, so but when x is equals to L, the tension must be mg. What the letter I should use? It should be capital letter M into g, but it is mentioned mg with a small letter m, right? So this point is wrong. Okay, so this is wrong. Let us judge the same here. So m plus m into g is right at x is equals 0, but when x is equals to L, right? When x is equals to L, the tension in the string is m into g. So this is absolutely right. So our option is second.